Hi everyone, welcome to Smart Interviews YouTube channel. Today we are going to solve the first three questions of LeetCode Biweekly 130. So let's begin with the questions. The first question given to us is check if the grid satisfies the conditions. You are given a 2D matrix grid of size m into n. You need to check if each cell grid of ij is equal to the cell below it, that is grid of ij is equal to grid of I plus 1j if it exists, and different from cell to its right, that is grid of ij, not equal to grid of ij plus 1 if it exists. Return true if all the cells satisfy these conditions, otherwise return false. So I hope the question is pretty straightforward. Let's look at the examples as well. So here the grid given to us is 102 102. Now the output is true. Let's see how. All the cells in the grid satisfy the condition. So if you look at the first cell 1, it is same as the cell below it and it is different from the cell to the right of it. So this satisfies the condition. Likewise 0 is same as the cell below it. 0 is different as the cell right to it, hence satisfies the condition. Likewise 2 is same as the cell below it and 2 does not have a cell to the right. So if you remember, the question said check only if it exists. So since this does not exist over here, we are not going to check. Now only checking the cell below is going to be sufficient for us. Hence 2 is also satisfying the condition. Now 1 does not have a cell below it, so we directly check the right. Hence true. 0 as well true. 2 does not have a cell below it, does not have a cell right to it, so no need to check at all. Hence it also satisfies the condition. Now since all the cells satisfies the condition, then I'm going to output the value as true. Let's quickly look into the second example as well. So the second example is 111000. The output is false. Let's see why. Now for 1, if you see the cell below it, it is not same. If it is not same, do you need to go ahead and check the cell right of it? No. Even if one condition is failed by one cell, the entire grid will return a false. That is what is told in the question as well. So checking one condition and failing that means you are going to return false. Hence here the output is going to be false. What about the third example? The third example is pretty straightforward. You do not have any elements to the right, you only have elements to the down. So for 1, if you check the element below it, it is not the same. Hence I return a false here itself. The constraints are pretty simple as well. So the number of rows and number of columns can go up from 1 to 10. Likewise every grid element can go from 0 to 9. Let's quickly write the pseudocode for solving this problem. So initially you start with traversal. You start with traversal through rows first. For I equal to 0, I less than n, I plus plus. Hence I'll start from I equal to 0 and go until n minus 1. Now inside every iteration of I, that is inside every row, I need to traverse through every element. So j equal to 0, j less than m, j plus plus. Here if you see the number of rows is given as m and number of columns is given as n, but we usually assume the number of rows as n and number of columns as m. So I have taken that representation. Let's mark that as well. N is number of rows, m is number of columns. Now for every element I need to check if the current element is same as the next row element. So if grid of I of j is equal to grid of I plus 1 of j. So if this is equal, do I need to do anything? No. I need to check for the other cells. Now if it is not equal, what do I do? If it is not equal, I simply return a false. Additionally, we also need to check if the cell exists or not, right? So if we do not check that and if we directly try to access the cell, we might end up in an error. So first let's check if the cell exists or not. That is by using if I plus 1 is less than the number of rows. If I plus 1 is less than the number of rows, it means that less than the number of rows means that the next row exists. So if this is true and my next row element is not equal to the current element, only then I return false. Likewise, what do? I then go ahead and check every element with its next column element. So for checking if the next column element exists, first I need to check if next column exists. If j plus 1 is less than m, if j plus 1 is less than m, it means that the next column exists. Now if the next column exists and the next column element is not equal to, here the next column element becomes grid of I of j plus 1. If the next column element is not same, then it satisfies my condition. Hence, only if it is same, then I return false, because if it is same, it is dissatisfying our condition. Hence, I return false. Now, if my loop has successfully executed without returning false, it means that all the cells satisfy the condition. Hence, outside the loops, I write a return true, telling that all the cells have satisfied the conditions. So without any delay, let's try to convert the same into code. That is grid.size, then m, that is the grid's number of columns, which can be gotten by grid of 0 dot size. So grid of 0 is going to get me the first row. The first row size is nothing but going to be the number of columns in my grid. Now I need to start with the traversal for int I equal to 0, I less than n, I plus plus. Then for int j equal to 0, j less than m, j plus plus. Now firstly, if my next row exists, that is if my I plus 1 is less than n and my grid of I of j, that is the current element, is not equal to the next row element, then what do? I simply return false. Now the next condition becomes checking if the next column element is different or not. So j plus 1 is less than m means that next column exists. Now grid of I of j is equal to the grid of I of j plus 1 means that the current element is equal to the next column element. If that is true, then I return false again. Now if my entire loop executed without returning false, it means that all the cells satisfy the condition, hence finally I'll return true by default. Let's quickly run and check. Accepted. Done. Moving on to the next question. Maximum points inside the square. So you are given a 2D array points and a string s where points of I represents the coordinates of point I and s of I represents tag of point I. A valid square is a square centered at origin 0, 0, has edges parallel to the axis and does not contain two points with the same tag. You need to return the maximum number of points contained in a valid square. Note that a point is considered to be inside the square if it lies on or within the square boundaries. The side length of the square can be 0 as well. So let's try to understand the question with the example given. Here the example given is points 2, 2, minus 1, minus 2, minus 4, 4, minus 3, 1, 3, minus 3. And the string given is A, B, D, C, A. Now you can assume the string as representing the name for the points for the different points given in the points array. Hence, for the point 2, 2 on the graph, if you see 2, 2 is over here and 2, 2 has the name A. Likewise, minus 1, minus 2 is over here and has a name B, that is the first index in the string as well. Then minus 4, 4 has the name or tag D. If you see in the graph, minus 4, 4 is over here and it has the tag or name D. So this is how the question is framed, that is you are given a points array which tells you on the graph where the points are and you are given a string denoting every points tag or name. Now, you need to get the maximum number of points that can be enclosed within a valid square. What is a valid square? A valid square is a square starting with its, start centered at origin. So origin is nothing but 0, 0. Any square centered at origin is firstly the square at 0, 0, you can say, because it was mentioned that the side length need not be, side length can be 0. Then the side length, if you take it as 2, it comes out to be this square with the origin as center of the square. Then for side 4, you find this square. Then for side uh, 6, you find this square. Likewise, side 8, so on and so forth. Your aim is to find what is the maximum valid square that can contain the maximum number of points. So to better understand, let's see how he has gotten the output of 2 for this case. So initially you can start with the 0 sized square itself. 0, 0, we do not have any points. So points contained in the 0 sized square. Points contained in the 0 sized square are 0. Then points contained in 2 sized square. Here the 2 sized square is this. Now inside the 2 sized square you can only see a single point, -1, -2, right? So -1, -2, okay, -1, -2 comes on the 4 sized square because it has -2 to it. So number of points inside the 2 sized square is also 1. Now the number of points, sorry, 0. Number of points inside the 4 sized square is, the 4 sized square is the blue square given over here. Here you have a 2, 2 and b -1, 2 as the points. So the number of points contained are 2 over here. What about the 6 sized square? The 6 sized square is one more square out of this. So something like this, and the number of points contained are 1, 2, 3 and 4. So there are 4 points, but if you try to recollect the question, it said that a valid square is a square centered at origin. Now here the 6 sized square is centered at the origin, has edges parallel to the axis. This has edges parallel to the axis. If it wasn't parallel to the axis, you could have gotten this as well as a square. But since he has told the edges parallel to the axis, we have been considering that, and does not contain 2 points with the same tag. So if you come back to this example of 6 sized square where 4 points are there, you have 2 points with the tag A inside the same square. That is 2, 2 has the same tag A, uh, along with the 3 minus 3 which also has A as the tag. If you consider the other 2 points, they are different, but our valid square should not have even 2 points with the same tag name. So until here, what was the maximum square we found with number of points as maximum? It was the 4 sized square, and it wasn't the 6 sized square. Now if my case failed at the 6 sized square, can I say that I cannot find an 8 sized square, 10 sized square, 12 sized square, so on and so forth? Because the 6 sized square itself has 2 points with the same tag name. Then any square larger than that will also have the points with the same tag name. So it is something like we found a valid square at 4. Hence, we might find a valid square at 2, we might find a valid square at 0, uh, and we found an invalid square at 6. Then we might not find a valid square at 8 or 10 or 12. So the pattern comes out something like this is true, 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 and from here on we start finding false. So this pattern tells us what? This pattern simply tells us to apply binary search. Now, why are we going for binary search? Why can't we apply the same thing for this problem? That is the brute force approach of considering every possible square and checking what are all the points inside it and checking if there are any two points with the same tag name. What if we do this? So, as per the constraints, if you check, the points can go from minus 10 power 9 to 10 power 9. If this is the case, then how many squares might you generate? It will obviously give a timeout. The time limit exceeded. Hence, for such a large search space, the best way to find after noticing this pattern is using a binary search. Now, what exact type of binary search are we going to use? We are going to find the last true, can I say? If we are finding the last true, we can simply use a floor binary search. We can simply use a floor binary search. Now, this is one way of finding the answer. If you are using floor binary search and your points can go up until minus 10 power 9 to 10 power 9, then your search space comes out to be around 2 into 10 to the power of 9. Log of the search space base 2 will be your number of iterations for the binary search, and for each binary search step you're again going to check for each point. So log of 2 into 10 to the power of 9 into 10 power 5, this is something like n log of r base 2. This logic is going to work. Now, can I somehow optimize the linear logic itself? I obviously found that the binary search logic is going to work fine. Can I somehow optimize the linear search logic itself? So, what about the linear search logic? So, let's go ahead with the linear approach itself and try to think how to optimize that. Now, if you observe, we are given with the points with tag names A, B, C, A, B, C, so on, and it can go only up till Z. So, if you check with the constraints, S consists only lowercase English letters. Now, if your S of I belongs to only these characters, then what does that mean indirectly? It indirectly means that the let the maximum sized square be any sized, the max number of points you can contain inside the square is going to be only 26 points. So even if you go linearly, if you know where all the points are occurring, then you will not exceed 26 iterations, because the 27th iteration you are going to definitely get a repetition. Now let's try to make use of this fact and solve this problem, and let's try to go the same way like we approached before, that is start with a zero sized square. So for zero size, do I find any point? I find a single point, let's say 0 0. I store it, and next comes the one sized square. Now until now, if I keep a track of what are all the characters I have faced until now, then it will help me stop at a point where I face a duplicate. So let's say I use some data structure. I do not know what data structure I'm going to use as of now. I use some data structure where I can keep a track of what are all the occurred characters. Now I got a Z until now. Let's store that. And apart from this, I got one point and I see that Z has never occurred until now using this data structure. Hence, this adds up to my answer, making my answer as 1 now. Now moving on to the one sized square, sorry, it's a two sized square. If I talk about the what do you say, the side uh, taken, I mean sides length, the edges length, two size square. Now for a two sized square, do I find any new points? I find a point 0 1 which has a tag x. Now, have I found any element with the tag x until now? No, right? I haven't found any tag x element. Hence, this goes into my data structure telling that I have found a tag, an x tag element until now. And what does this make my size now? This makes my size 2 because I found one more point until now, or let's say this is 1 itself. At the end, we can try to add it up if required. So, what comes next? The 4 sized square. If I take the 4 sized square, what are all the points I come across here? For the 4 sized square, I come across the points 2 2a, then 2 minus 1 y, and then minus 1 minus 2 b. These are all the points that come across inside a 4 sized square. And now let's try to iterate through these points and see if I can insert all these points inside my valid square or not. So if I'm able to insert these values, insert all these values inside my valid square, it means that I have found these many points and my valid square's size has now increased to 4. So let's start. I'm first at 2 2 with a tag A. Now, does the point make any difference to us? I just need to know which square is this point coming into. But other than that, what makes an impact is the character or the tag. Now, have I found a tag A element until now? No, right? I found only tag X and Z elements. Hence, I can insert this element with tag A. So, this goes into my answer. Next, I get an element with tag Y. If I get an element with tag Y, does my Y tag element exist in my data structure? No. So, again, I insert this tag again. This has been inserted into our valid square. Next, I move on to the next element where I find minus 1, minus 2 with the tag B. Have I found an element with tag B until now? No. Hence, this also goes into my square. With this, what do I say? I have found now 3 elements that are unique and have not been added into my valid square yet. 3 unique tag elements, you can say. Next, after the 4 sized square, what comes next? The 6 sized square. So for the 6 sized square, if you see, uh, the 6 sized square elements here are first is 3 0 f, then minus 3 1 c, then 3 minus 3 a. Now coming into the first element 3 0 f. Does the element matter to us? Does the coordinates matter to us? No. The coordinates are helping us find which square is it coming in, whereas the character is what is making an impact. Again, have I found an f element here? No. So insert it. This goes into our valid square. Then minus 3 comma 1 comma c. Have we found a c element? No. So this also goes into our square. Then I find an element with the tag a. Have I found an element with tag A already? Yes, I have already found. I already have found an element with tag A, which means this is a duplicate now. Now, can I have 2 points with same tag name inside my valid square? No. Hence, can I say that this entire 6-sized square is going to be invalid? Right. Even if one point is invalid, even if one point is a duplicate, it means the entire square or whatever are the elements that are coming into by this level are also invalid. So I stop my linear traversal here itself, and until now whatever were my points I gathered, if I add them all, what comes out to be my answer? My answer comes out to be 5. Now if you see for this example, the max sized square is again going to be the 4 sized square, and if you see the number of points inside this 4 sized square, you have 1 2 3 4 and 5. You have 5 points. Hence, is our answer valid? Yes. Now our main agenda is, firstly, How do I get all these points for my each of the squares? So if you observe, for every coordinate, you can map it to the sized square it needs, the minimum sized square it needs to envelop it. For 0 comma 0, it is going to be 0 sized, obviously. For 0 comma 1, why are we taking into a 2 sized square? Now 0 comma 1 means that it is at a maximum distance of 1 from your origin or from your origin's level. Uh, Now, what do I mean by origins level is it can be either your vertical level or horizontal level. So here the 0 comma 1 comes under the level 1 square, you can say. The size being 2, it means that, let's say 0 comma 0 is your origin. Now from this origin you can find this point at one distance is what I mean by this is at a distance 1. So here we found it at 0 1. How are we finding that, or how are we telling that this comes into this one, I mean the one level above the origin level? So this is nothing but signified by the coordinates itself. Let's go to the next example which will make you understand better. Now moving on to the next example, you see that 2 2 is your point now. 2 2 point means that it is at a distance of 2 or 2 levels from your origin. Let it be a vertical level or a horizontal level, but the minimum distance you need to cover from origin is going to be 2. That is 2 squares from the minimum, sorry, the origin level. That's how we came to the 4 sized square, which is 2 levels below the origin level. So there is this x coordinate, this y coordinate. What will help you get this minimum square that is required to envelop this point? It is going to be the max of x and y. Here the x is the x coordinate and y is the y coordinate. The maximum of both the coordinates will tell you what is the minimum sized square required to envelop that point. Now, with that being said, this is a 0 level square, this is a 1 level square, this is a 2 level square, this is a 3 level square. What do I mean by level is the distance it took to cover from the origin. So this would be a 1 level squares distance covered. Then this would be the distance needed to be covered by 2 level square. Then if you talk about the 3 level square, this would be the distance covered from the origin for 3 level squared points. So the size and the level are something like level equal to size by 2. What matters to us is not the size or the level. What are all the points coming under this category? Let's take the level itself, because level is directly being gotten by max of x comma y. Now with this level, I can say that this point comes under this level. You need a data structure that can maintain for an integer a list of points. Now here again, as discussed, you need not maintain what are the points. You just can maintain what are the characters, because the characters are what makes us decide to take it inside the valid square or not. So you need to maintain something like an integer to an array of characters. What can you use simply? You can use a map. Now talking of C++, you can use int comma vector of characters. This will help us store what are all the characters occurring in a single level. Now, by expanding this level from 0 to 1 to 3 to 4 to so on until the maximum level, I will at most go across 26 such levels. Now 26 levels doesn't mean the distance 26, rather 26 unique levels. So it could be anything from 0 to 10 power 9, but only 26 among these, that is 26 unique elements among this range, will help me get the number of points, maximum number of points. So I'm going to maintain a map. What type of map do I need? Do I need a hash map or a tree map? I need to go one by one level. So the best way would be using a tree map, or I can also use a hash map, and I can maintain what is the maximum level until now. So that could also be done, but using a tree map is even more efficient, because if you are using a hash map, you need to know what are all the pinpoint levels. If you use a tree map, a simple iterator would be sufficient to help you with the solution. Now, what is this data structure that helps us keep a track of what are all the points that we faced until now? I need to directly check if this character has occurred. If it does not occur, I need to insert that character into this data structure. So what would I use? For this purpose, I can simply use a set of characters. So I'm going to use a map of int comma vector, and I'm going to use a set of characters. Now map of int comma vector should be first filled. After filling, I need to iterate level by level and fill in my set of characters. Even if one point fails in any level, I am going to stop my iteration entirely, and whatever is the sum until there is going to form my answer. Let's implement the same solution that we discussed. You can also go for the implementation of binary search. Again, in binary search solution, you need to check what are all the points that are occurred inside that valid square. So let's jump to the solution part now. Now starting with the solution, firstly I need an ordered map. So I'm going to use a map of int comma vector of character, an ordered map of int comma vector of character. This is a tree map. So let's take the variable name as tm. I need to know how many points are there. So how many points are there can be gotten by points dot size or s dot size as well. Both work fine. Let's take s dot size. Now I need to iterate through each point, and I need to put that into all the square levels. So for int I equal to 0, I less than n, I plus plus, I plus plus. First I need to put this point, sorry, first I need to know which square level it comes into, and which square level it comes into is being found by the points as x and y coordinates. So points of I is x coordinate is at 0 and y coordinate is at 1 index. So points of I of 1. Now this will get me what is the level of the current point, what is the square level of the current point. I first need to check if this square level exists in my map. If it exists, I need to go ahead and push this value back, and if it does not exist, I need to create a new vector and push the value back. Now what value do I push? I push the tag. So tag is gotten by s of I again, and again this is going to be a character tag. First I need to check if this exists in my tree map. So I can use tm.find of level. Now if this is equal to end, it means that the level does not exist. So tm of level is going to be a new vector of type character, and tm of level is going to be pushed back by the tag. Now else what do? I already have a vector at that level. I simply push back the tag. If you observe, the pushing back the tag is same. So I can remove from one of the blocks and put it common to both the blocks. And if this is the only line going to be executed in the else block, that is anyways going to be part of our main logic. So remove the else block. And That's it. With this, I'm going to get the sorry. With this for loop, I'm going to get all the points tags pushed back into that respective levels. Now, after this, I need to have a set. Instead of using an ordered set, I can use an unordered set because I do not need to access the set anyways. I just need to check and insert. So, unordered set of type character, let's say hash set. Now, for every level, I need to start iterating. I can take an iterator. So, you can take mm, map iterator of type int to vector char, let's say it equal to tm dot begin, then it not equal to tm dot end, and then it plus plus. Now I have started iterating. After iterating, I first need to get what is the uh, character sorry, what is the character at the current level, what are all the characters at the current level. So I can get that using it dot second, and since this uses references, I need to get it dot second like this. This is going to be the character vector, uh, current level, you can say current levels character vector. Now I first need to iterate through this character vector. So for char C, I do not have any work with the indices. I can use a for each loop. Current level if hs dot find of C is equal to hm dot end. Sorry, it is not hm. This is hs has set. If it is equal to the end, it means that the current character has not occurred until now. Hence, I first push that into my set, and I only push it into my set. Now, if that already exists, then I need to return what? I need to return the answer. Do I have my answer anywhere until now? No. So first take the answer, answer equal to 0. Uh, Return answer. Now, if my current levels characters are the first occurrences, that is, they haven't executed this return answer part, then all these characters come into my valid square. So after the execution of the for each loop, I go ahead and add all the current levels characters into my valid square, which means my answer needs to be incremented by the size of the current level. That is whatever are the number of points held at the current level. Now with this, I have a track of what is the number of points until the current level I have seen, unique points until the current level I have seen. Finally, I return the answer. And when does this execute? When all the characters are unique. So let's quickly run the code. Map request template arguments. Okay, maybe this goes over here. Okay, it is insert hs dot insert. Wrong answer. Okay, so we forgot one thing. Now, if you observe, what is the minimum sized square required to contain minus 4, 4? You can directly say that maximum of these is going to be 4. Now, what if the point is something like minus 1, minus 2? If it is minus 1, minus 2, you definitely know that it is going to be 2. But if you take it in terms of math, that is, you used a math.max, right? So, if you observe in the code, we have used max of the points. So max of the points is going to return in this case -1. But what is the level we need to consider? We need to consider level as 1. Hence, what do we use? We need to use absolute. So let it be -1, let it be 1. It will be accessible at the first level. So absolute of this points, that is the x coordinate or the y coordinate, is going to give you what is the level it is accessible at. Absolute of points of I of 0, points of I of 1. Let's run. Let's submit. Done. So make sure you try the binary search logic as well. It is a bit interesting. You should be giving it a try ideally. Let's move to the next question now. Let's start with the next question. The next question is minimum substring partition of equal character frequency. Given a string S, you need to partition it into one or more balanced substrings. For example, if S is equal to AB, AB, C, C, then AB, AB, C, C, or AB, ABC, C. And one more string are valid partitions, but a few more strings are, I mean, a few more partitions are given here and are told are not valid. The unbalanced strings are bolded. So what he means here is the BAB, the ABA, the ABCC are all unbalanced. Now he needs us to return the minimum number of substrings that you can partition S into. He has also given us what is a balanced string. What he means by balanced string is a balanced string is a string where each character in the string occurs the same number of times. So that is why BAB or ABA or ABCC are all unbalanced because B occurred twice whereas A occurred only once. A occurred twice whereas B occurred only once, and ABCC, A and B occurred only once but C occurred twice. So these reasons make it unbalanced strings. Now, let's try to understand with the examples. So you're given the first example FABCCDDG. So FABCCDDG. Now, if this is the given string, you need to make it into substring partitions such that all are balanced strings. Individually, all these substrings are balanced strings. So what you can do, you can go ahead and create a partition with only F, or you can also create a partition with only FA, or you can also create a partition with FAB or FABC. When you go to create a partition with FABCC, now we cannot create another partition. I mean, now we cannot create a partition over here because C occurred twice. So if this is not giving a valid partition, then you need to go ahead and search for any more characters that can equalize the other characters frequency, making it 2. That is something like FABCC came, and next you need to get ABF or AFB or something like this to make it a balanced string again. So now let's say you picked FAB as your first string partition, first substring partition. You need to again go ahead and create substring partitions from here. Now, if you observe, the CCDDG can be told as the smaller subproblem of the exact same problem which is large. That is FABCCDDG is a larger problem, and CCDDG came out to be a smaller subproblem of the exact same problem. So ultimately, what can we use here? We can simply use a recursion here. Now, to write a recursive code, there are 3 steps that we follow: assumption, main logic, base condition. So if you start with the steps, let's take function f is going to be our recursive function. So it takes in the parameters string, and apart from the string I need to know what is the size of the uh, string, and I need to know from where I am going to partition the string. So let's take int index. This, let's say, is going to be a recursive function, and our assumption here would be something like uh, f function would return, f of s n index will return the number of partitions that can be made. But do we simply need only the number of partitions? We need the minimum number of substring partitions that can be made. That is, if you assume for the given example itself, we need not find if we can make it into partitions or how many partitions we can make it. We are asked to find what is the minimum number of partitions. So, as discussed, you can make a partition at FAB, or you can also make a partition at FABC. Now, if you make a partition at FABC, then you are forced to make a partition at CD, and because CDD would make it invalid, CDDG would also make it invalid. So you are forced to make a partition until the first D, and after this, you are again forced to make a partition until DG. Is there a better way of doing the same? You could also try FAB, CCDD, and G. Now, in the previous partitioning as well, we got three partitions. Here as well, we are getting three partitions. We could also try something like FA, BC, CD, DG, for which we are getting four partitions. Among all these, we need the minimum number of partitions that we are needed to make, or that we can partition the string into. Uh, a better example would be something like if you take, let's say, CDGG. Now, FAB would be a partition, or if you make FABC as a partition, then CD would be a partition, DG would be a partition, G would be a partition. Instead, a better way to partition would be, for this we are getting 4 as the number of substrings. Instead, a better way could be simply FAB and CCDDGG. This would get you two partitions. So among 4 and 2, 2 is the best way you can partition. So among 2 and 4 being the ways to partition, you need minimum. Hence, what would your plan of action inside this function be? Firstly, I need to check if the substring is valid or not. Only if it is valid, I can make a partition. If it is invalid, I cannot make a partition. I need to go on ahead and see to that if I can get any more characters to make this a balanced string. Now, what do I mean by valid? I mean if it is a balanced string or not. How can you check if a string is balanced or not? Let's say FAB itself is your substring. How can you check if it is balanced or not? To check if it is balanced or not, you can keep a track using a hash map or a counter array. Now, using the counter array, you can see what is the occurrences or frequencies. If all the frequencies are same, then continue telling that it is a balanced string. If all the frequencies are not same, that is, even if one frequency is not same, let's say FABCC is your string. For F you have 1, for A you have 1, for B you have 1, for C you have 2. Even if one of the frequencies is not same, then the entire substring becomes invalid. You need to keep searching for better substring. So from the current point, until which point can I create a substring? Until the entire string I can create a substring. So the first step here is going to be the assumption. The assumption will now give us will give the minimum partitions, minimum parts that can be made from index. Minimum partitions that can be made from the index. So if it is giving the minimum partitions, the return type becomes int. This is going to be a recursive function. Now coming into the second step of any recursive function, that is the main logic. Coming into the main logic, firstly I need to check if the current string is valid or invalid, and I can create a partition from the current index to the end index. So let's say an unordered map is going to help us keep a track of what are all the number of occurrences of characters. You can also take a count array. Let's take a count array here in this case. So cnt of size 26 because there can be 26 characters, and you need to initialize all with zeros. This is not the exact syntax to initialize with zeros. You need to use the fill function, which we'll be using while writing the code. So int count 26 equal to all zeros. Now I need to start iterating for int I equal to index. I can partition until the very end I less than n, and I should be incrementing in each step. Index, and I can go until the last element. Firstly, I need to include the current character into my count array. So count of s of I. What is going to be the index of s of I? It is going to be simply s of I minus smaller quotes a, because it was already mentioned that your s is going to have only lowercase English alphabets. So s of I minus a, and since we have already initialized with 0, we are going to simply increment. Now first I need to check if the current partition is valid or invalid or balanced or not. So if is balanced of, do I need the string? I have the count, or I'm keeping a track of how many characters are occurring in the count array, and count array is what is going to decide if my string is balanced or not. So I only pass in my count array and I ask if the count array is balanced, that is if the current string partitioning is balanced or not. Now if it is balanced, then I can partition from here. Hence the number of steps to partition from this point on is going to be 1 plus 1 partition at this point, plus I need to know what is the minimum partitions I can make from the current index plus 1. What is the current index? I plus 1. Do I have any function that will tell me what are all the minimum partitions I can make from the current index? I have my f function. So f of s n, and this time the index you are going to pass is going to be I plus 1. Now this f function call will give me what are all the minimum partitions I can make. After getting the minimum partitions, this can be eligible for my answer, and I need the minimum possible answer. So let's initialize the answer first. Answer equal to int max, because I need the minimum. If this is true, then my answer is equal to minimum of answer comma 1 plus the minimum number of partitions to be made from now on. This one is signifying that we are placing a partition at the current point. Now if the counter is imbalanced, or if the string partition is imbalanced, do I need to care about partitioning? No, right? I can simply continue until the counter array becomes balanced. So this is it for my for loop, and at the end of this logic, what can I say? I can say that answer will hold my minimum number of partitions. So finally I'll return answer. Now the second step, that is the main logic, is also done. What is the third and the final step in my recursive code? It is going to be the base condition. What will my base condition be? My base condition is going to be, since I'm going in an incremental fashion, my last case would be n, my index being n. If my index is n, what does that mean? It means that I have partitioned the entire string, and now I am at a point where the string has ended. So if I am at the end of the string, that is if index is equal to n, then I simply return what? I need not make any partitions from here, so I return 0. I return 0. With this, my entire recursive function is done. Now, if you observe the constraints and if you observe the logic time complexity here. Now, if you consider the time complexity of this code, we usually calculate the time complexity of recursive code using a recurrence relation. So let's say I take t of n time to partition n sized string. Now, if this logic executes and if I'm calling this function, I'm calling from I plus 1, which means one character might be less, which means I'll take t of n minus 1 time in the worst case. So, and this loop again is going to take n time to execute. Entire recurrence relation comes out to be t of n equal to n t n minus 1 plus 1. This plus 1 represents some constant time taken to perform other statements and operations. So if you expand this expression further, you are going to get a complexity of around n cube, which means for the given constraints, that is n can go up until 1000, your logic might fail. So let's see the application of dp in the code itself. You are going to apply dp because we can find overlapping subproblems here, as well as we are finding optimal substructure. Since both these characteristics are being found in the current solution, we can apply dp. Let's see how in the code. Now jumping onto the code part, firstly I need the size of the string is dot size, and as discussed, I'm going to use a helper function which will tell me how many minimum partitions are required. So why am I taking the helper function? Because in LeetCode I cannot modify the method signature as per my requirement. So I'm going to take a helper function which accepts a string, then the size of the string and the index from where it should be partitioned. So now coming to my helper function, int helper string s int n and int index. Now moving on to the main logic part, I hope everyone remembers the assumption. Moving on to the main logic part, first I need the answer variable. I need the answer variable to be uh, a maximum value. Let's take int max, and let's start with traversal. For int I equal to 0, we start from index. For int I equal to index I less than n I plus plus. Then now if I'm partitioning this, if I'm considering to partition this, I need to keep a track of how many characters of each character have appeared until now. So let's use a count array of size 26, and we need to fill in the array elements with 0 initially. So count plus 26 the size and 0 the initial value. Now, after filling, first count of s of I plus plus s of I minus a to make this character go to an index. With this, I'm taking this character into my substring. Now I need to check if my substring is balanced or not. If is balanced of my count array, then what do I do? I need to partition from this point on, and I need to keep a track of what is the minimum answer. So 1, because I'm partitioning at this point, and I need the helper function to partition from I plus 1 on the string of size n for me. This will tell me how many minimum partitions I make from this point on, and plus 1 signifying that at the current index as well we are making a partition. Now for this is balanced function, let's write the code here itself, and let's say I'm using a flag. So bool flag, which is initially true. I need to iterate through this count array. So let's say C is the count, and let's keep a track of what was the previous count until now. Initial previous count, let's take it as -1. Now, if my count is 0, it means that my character has not occurred. I can simply ignore and go to some other character. If my character is not, I mean, if the character count is not 0, it means that this character has occurred some number of times. If my previous is -1 in this case, where the first character has occurred sometimes, then this is the first character, hence take the previous as the current count. Else, if previous is not equal to the current count, then it means that the current count and the previous character's count are different, hence my string is imbalanced. So make the flag as false and break the loop now. With this, my balanced check is going to be done, and if my balanced check returns true, I'm going to partition from here on. Else I do not partition anything, I simply keep moving forward. Finally, I will return whatever is my answer. Now, what about my base condition? My base condition is if index equal to n, I return 0, because at index equal to n, I cannot make any more partitions. Let's quickly run the code. Okay, n, I less than small n here. Accepted. Let's submit. As discussed, we are getting time limit exceeded because of the uh, constraint. So let's simply convert this. Let's quickly convert this code to a DP code. So for a DP code, I need a vector of type integer named DP, and for each string, I'm going to reinitialize this vector with the current string size and the initial values as -1. If my DP of I is -1, it means that the current index has not yet been visited. Now, I can pass this DP as a parameter to the helper function as well, or I can also simply take it as a class variable like I have done here. So above, I simply go and first, before starting with the main logic, I check if my DP of index is equal to -1 or not. If it is equal to -1, I need to execute the main logic. If it is not equal to -1, whatever is the DP at the index value, I return it. Now, after this, if I'm not returning, it means that my DP at index is still unvisited. So I start with the traversal, and I keep calculating the answer, and finally, before returning, I assign this answer to my DP at index. With this, my conversion to DP is done. I accept it. Let's submit it. Accepted. Before solving this problem on DP, make sure you solve a few more problems on DP on interview bit and LeetCode, and then come to this problem and try to understand the logic, guys. Hope you liked the video. Please like and share the video if you got benefited. Subscribe to Smart Interviews for more such content. Thank you. Arun signing off.